Hi everybody. Today we are going to go to the next module, which is digital electronics. In this real world, when everything is moving towards digital, we should understand the basic fundamentals of digital electronics. This module will be covering various content of basics of digital electronics. We'll start from the number system. We'll proceed to binary arithmetic operations, where we do some additions, subtractions, multiplications, and do some little bit of ones complement and twos complement operation, and we'll be focusing on the basic logic gates and the derivation of Boolean algebra. We'll be seeing the postulates, theorems, we'll be solving some equations using Boolean algebra. We'll be trying to implement some digital circuit design with having the basic knowledge of all this. And we'll be covering a little bit of mapping, solving or minimizing the digital expressions. So now in this particular video lecture, we'll be focusing only on the number system and the number conversion, that too particularly on decimal to other number system conversion. To start with, we have to understand the various number systems which are normally available. So as you all know that we are focusing on the decimal number system. You call this decimal number system when you represent the decimal number system to the base 10, or you have a radix as 10. Similarly, the binary number system would be represented as the base 2. The octal number system would be represented as the base 8. The hexadecimal number system would be represented as the base 16. So now when you do this, we come to know that these are the number systems prevailing around us. So now we'll be focusing much deep onto this particular number system. As you can see here, I have given you a counting happening in the various number system: decimal, binary, octal, and hexadecimal. So keep in mind one thing: 0 to 9 is what you have in decimal number system. Binary, you'll have either 0 or only 1, right? Only two variables. Octal, you have 0 to 7. The maximum is 0 to 7. Hexadecimal, you have 0 to 15. Since 15 is in decimal, we will be representing hexadecimal is a unique value number system, where this 15 would be represented as F. So we'll be seeing that a little bit detail. So now you can see here, I have given you numbers starting from 0 to, you can go up to 21. This is the decimal number system. So why I wanted to show you this is, I want to show you a unique feature where all the number system follows. So I have given you 0 to 9, right? 0 to 9 is what your decimal number system is. So up to 0 to 9 over here. So see here what happens after 9, it is 1 0. And binary number system I have given 0 to 1, right? 0 and 1. What happens after 1? It is 1 0. Octal number system 0 to 7. What happens after 7? It is 1 0. Hexadecimal number system, it is 0 to F. F after F, what happens? It is 1 0. So now this is very common. So that is how you have to remember. That is how you should know what is the number system is, right? This is the maximum number. After that, you'll have 1 0. This we call it as 10 in decimal number system. This is 1 0 in binary number system. This is 1 0 in octal number system. This is 1 0 in hexadecimal number system. We cannot call the same binary as 10 octal. It should be called as 1 0 only. So only for decimal number system you have this 10 value and all. Right? Hope you have understood this. Now in the next following chapters, we'll be seeing how to convert a decimal number system to its equivalent binary number system, a decimal number system to its equivalent octal number system, a decimal number system to its equivalent hexadecimal number system. This is what we are going to see. So now I have given you this particular chart saying that we can convert one number system to any other number system, and it can be done vice versa also. So we can even convert an octal to hexa, hexa to octal. This can also be done. So we'll be seeing all this one by one. We'll go stage by stage. So now the first one, decimal to binary conversion. Basic step is, take the decimal number system, divide it by 2 and keep the remainder alive. Don't take the fraction, just keep the remainder alive. Divide that number until when you cannot divide that number by 2. Why we are giving 2? Because why we are dividing it by 2? Because the binary of the binary number system radix is 2. So when you want to convert a decimal number system to any number system, only step is you have to take that particular radix or the base and then divide it. So divide until the number which cannot be divided more than by 2. And what you have to do is you have to take all the remainders. So all the remainders were alive, right? So take all the remainders and write from bottom to top. What is bottom to top? I'll let you know with an example. Now see here, I have given you an example like 234 is the decimal number. I'm going to convert that number to binary and I have given you the answer. Now let us check how this answer is achieved. So now we'll start to do the number system conversion. So 234. What we are going to do, the step is divide. So which number system are we converting? We are converting into binary number system. So the radix of binary is 2. So 2 ones are 2, remainder is 0. 2 ones are 2, remainder is 1. 7 twos are 14, remainder is 1. Sorry, 0, right? Divided by 2 again. 5 twos are 10, 8 twos are 16, remainder is 1. Divided by 2, 2 twos are 4, 9 you get, 18, remainder is 0. Then you divide it by 2 again, 1 twos are 2, 4 twos are 8, remainder is 1. Again you divide it, 2, 7 twos are 14, remainder is 0. Again you divide it, 2, 3 twos are 6, remainder is 1. Again you divide it, 2, 1 twos are 2, remainder is 1. So now what you are going to do is you are going to write from the bottom to the top, right? That is what the procedure is, from the bottom to the top. So you can see here 1, 1, 1, 0, 1, 0, 1, 0. Check with the answer, right? 1, 1, 1, 0, 1, 0, 1, 0. Did we get the answer? If you write this to the base 2, this is your binary number system. So I have indicated two important part, which is most significant bit. This bit, right? To the leftmost side is the most significant bit. The least significant bit is the rightmost part. So in binary, you have to remember one thing. So when you say bit, it is either 0 or 1. That is called a bit. If 4 bits together forms, then you call it as a nibble, right? 4 bits together is a nibble, right? And if 8 bits forms together, you call it as a byte. If 8 byte forms together, or if you say if 2 bytes form together, you call it as a word, right? That keeps on, word, double word, that keeps on. This is the basic funda that you have to understand. So now we have converted a decimal number system to its equivalent binary number system. The next one, we are going to convert an octal number system. We are going to convert a decimal number system to its equivalent octal number system. The same step, right? What we are going to do, we are going to take the decimal number system divided by 8. We have to divide until you cannot divide it much further. Take the remainder and write it from the bottom to top. So now let us take this example 234. So 234. Now we are going to divide this 234 with the radix 8. Right? 2 8s are 16. You get 74. 9 8s are 72. You get remainder as 2. And then we can divide it by 8 again. So 3 8s are 24. We will get the remainder as 5. So now we can see here we cannot divide it more by 8. So the answer is 352 to the base 8. We got the answer correct. Right? Simple. Right? We will try to do the next conversion. The same one, take the decimal number system, divide it by 16. Right? Divide it by 16. You have to divide until you cannot further divide it by 16 and write the answer from bottom to top. This is the correct one procedure. So now we will take the same example 234 divided by 16. So it goes by ones, and then we will have 14. Then the remainder is 10. So now what I did was I did it in decimal number system, right? We are not supposed to do it in decimal number system. So for understanding purpose, I have done this, but we can change this decimal number system to hexa. So what we are going to do? So for 14, you have to know what is the hexadecimal value. So remove, just to recall, 0 to 9 would be same for decimal number system. So in hex also 0 to 9 and decimal also 0 to 9. So for 10 it is A, 11 it is B, 12 it is C, 13 it is D, 14 it is E, and 15 it is F. So now check for 14. 14 is E, right? I'll just write E over here. And what is for 10? It is A. So I have to write from bottom to top. So I can divide more than this, right? So EA is the answer. So now with this we have converted a decimal number system to its equivalent binary, octal and hexadecimal. So hope you have understood this. We'll be seeing further in the classes. Okay, thank you.